Now let's look at one more example of two sample t-test with underlying samples assumed to have equal standard deviation. So here we are testing whether the delivery times for a local pizza restaurant is the same as a national chain. So you collect data by ordering 10 pizzas from the local pizza restaurant and 10 from a national chain at different times of the day. So you organize the data in this file. So table 10.2 shows the delivery times, the local restaurant and the national chain. And we want to test whether the local restaurant delivers faster than the national chain. So that's the purpose of this study. So let's go to the Excel file. So here we need to first define X sub 1 is delivery time for local pizza restaurant, and mu sub 1 is the mean of the local delivery times of the local pizza restaurant. X sub 2 is the delivery time for the national chain, and mu sub 2 is the average delivery time. Now we want to test whether the local chain can deliver faster. So we set up the alternative hypothesis first. Mu sub 1 is less than mu sub 2. The null hypothesis is the opposite. So let's assume 5% alpha. Now the data is given here, local and the chain. Okay, again we set up count for local, okay, average for local, and then standard deviation for local. And we copy that over. Okay. Now the assumptions required, again, since the sample sizes are small, we have to assume that the underlying population is normal and the samples are independent random samples and the underlying population standard deviations are equal. Okay, and now we compute pooled variance estimate. So we can do the pooled variance estimate piece by piece or all at once, and I would advise you do piece by piece. That way, we can avoid possible mistakes. N sub 1 minus 1 times the standard deviation squared. Copy that over. Okay, so now add the two, so you get the numerator part. Now n sub 1 plus n sub 2 minus 2, so that's the degrees of freedom. So pooled variance estimate would be that divided by that. Okay, now standard error is square root of the pooled variance estimate times 1 over n1 plus 1 over n sub 2. Okay, now t stat is x bar sub 1 minus x bar sub 2. The right hand side of the hypothesis is 0, so we need to divide by the standard error and we get the t value. Degrees of freedom is n sub 1 plus n sub 2 minus 2. A critical value approach will be t dot inv dot 2. Now this one is one tail test. So t dot inv dot t dot inv 5% comma degrees of freedom will give us the t value. Okay, so the conclusion is 1.63 is greater than 1.73. If you imagine the normal distribution curve, so 1.73 is farther to the left than 1.634, so we cannot reject. Okay, we cannot reject. The p-value approach. So here this is a one-tailed test on the left side. So we need t dot dist and t dot dist on the left side. So we have to use the t dot dist function. Now cumulative probability is what we want, so we can just use the t stat value, comma degrees of freedom, and when we use the dist function you have to say we want the cumulative probability. So that gives us a p-value that is greater than 5%, so we cannot reject. And the interpretation. So there is insufficient evidence to conclude that the average delivery time for the local pizzeria is less than that of the national chain. If we concluded that it was less, then the probability that we are wrong, we are making type 1 error mistake, is 5.98. Now let's develop a confidence interval for the difference in the two population means. We are continuing with the same problem like before, which is the delivery time for local pizza restaurant and the delivery time for national chain. So we want confidence level of say 95%. We want 95% confidence interval. Now degrees of freedom, we already found degrees of freedom here, so which is 18. Now x bar sub 1 minus x bar sub 2, here is x bar sub 1 minus x bar sub 2. Okay, so now we need the t table value for confidence interval. So we get t dot inv dot 2t, and the probability is 1 minus the confidence level. We want the alpha value, so that's 1 minus the confidence level and then the degrees of freedom. Okay, now the standard error of estimate, okay, same as before, we've already computed that here. So we take that. Okay, margin of error is t table value times standard error of estimate, then the point estimate minus margin of error is the lower limit, and point estimate plus the margin of error is the upper limit. And since the interval contains 0 in it, that's another way of looking at the hypothesis test here. And because of that, since 0 is part of our 95% confidence interval, we cannot say that the means are different. So now interpretation is that we are 95% confident that the difference in the population means will fall within that range.